What's going on, you guys? So today we're going to work on Elements of Programming Interviews 13.1, intersection of two sorted arrays. So the idea is you have two arrays and you want to return another array with the intersection, with the values that are intersecting in these two arrays. So our game plan as we solve this, we're going to first go over a brute force solution. We'll write pseudocode. We'll talk about space and time complexity. Then we'll think about an optimized solution. We'll write pseudocode, space-time complexity, and then also an implementation in Python. So let's think about brute force. So how could we, if we have these two arrays, how could we find the intersection? Let's say we have this intersection. We want to find out what elements are in both of these. Well, we could go through each value in each array. Like say we have 2 pointers, the index starting from the first value going to the last value, and we can go over them, and if these two indexes equal, then we can add it to our intersection array. So we could start here and we could see 2 and 5, no, and 2 is less than 5, so let's increase I. Now we compare 3 and 5. 3 is less than 5, so we'll increase this again. We get 3 again, so we'll keep going. And now we see that we found a value in common. So we want to add this to our intersection. So we'll add 5. And then we add an intersection, let's increment both values. Okay, so we check here and we've already seen this value, so we want to skip this. And what do we want to do? So because they're equal, we're going to increment both values. Okay, so now we see a value that we haven't seen before, and I and j are equal in this case. So let's add their value to our intersection. And let's increment both. Okay, so now I is less than j, so let's increment I. I is still less than j, so we increment I again. Now I equals j, so let's add that to our intersection. So we're going to keep going. Now j is less than I, so we're going to increment j. J is still less than I, we increment. J is less, so we increment. J is less, so we increment. And j is less, so we increment. And now j is greater than, we've gone through all elements in B. And so at this point, we're going to exit out of a potential loop that we're writing and return our intersection. So the answer for these two arrays, what's the intersection between A and B? It's 5, 6, and 8. And this is how we're going to find it. We're going to loop through, we're going to keep 2 pointers, going from the first element in each array to the last element. And while we're not at that last element, we'll compare the values associated with those 2 pointers that we have. So let's think about let's think about some pseudocode, and then we'll write space and time complexity. So let's think about this. So we'll say I and j equals 0. We're going to loop over the indexes of these arrays, and indexes are 0 index, so they start at 0. And we're going to create a loop, and we're going to go while I is less than the length of A, and j is less than the length of B. And both of these must hold, right? So in this case, we got to the end of A, and j went to here. J became greater than, it went beyond the values within B, and so we would exit out of our loop. So we're going to set these values. We also need, so we're going to say this is 0, and we're also going to set LA, we're going to refer to that as the length of A, and LB, we're going to refer to that as the length of B. We're going to set that to length of A and length of B. So we've got these two arrays, A and B, and we're looking to find the intersection. So we're writing pseudocode, we're starting Okay, so what are we going to do as we loop through our values? So let's think about this. So when I is 0 and j is 0, in this case ai is less than bj, so we're going to increment I. Okay, so that's a rule. Let's say if a value, if a is less than, if I is less than j, we're going to increment j. Or increment I, sorry. And now let's think about when was j, let's see, so, and then else if j is less than I, we'll increment j. Otherwise, what are we going to do? Otherwise, they're equal. So let's think about what we did when they were equal. So in this case, I got to here, and then they were equal. So we know. So we're gonna have this. We're gonna have intersection as well. We know when they're equal. We want to append to intersection. We're going to append, either ai, either I or j. They're both equal, so it doesn't matter what. But what else are we going to do? Are there any special cases? That's what we have to think about. So in this case, we appended 5, right? We got to this point. We appended 5. We increment I and j. Okay, so when we're appending to intersection, we're also incrementing I and j. We're going to say I and j equals I plus 1, j plus 1. Okay, what else? So we increment these values, and then we see the same 5 again. So now we don't want to append 2 5s. We don't want to have 2 5s here. Let's think about this. So we'll say if we can choose one, we can say if I does not equal its previous value, then we'll append it. And so we would still append the first 5, but when we get to the second 5, because the previous value here is 5, we're going to skip this 5. So we're going to go boom. Boom. Okay, so how would we write that in code? We would say if I, let's think about this. If I does not equal previous, then we're going to append. We're going to append I. Okay, what else? Well, what about what if we had this? 2. What if this happens? How can you can't check if I equals its previous value here because it doesn't have a previous value. So we're going to say if I does not equal its previous value, or if I is first element, or I does not equal previous value. Then we'll append I. So in this case, so say we have these two arrays. Because I is 0, I is the first element, we're going to append 2. We're going to append 2. And this is what intersection will look like after we append it. And we increment both values like that, and we move on. So is there anything else? Let's think about what else we could be doing. Okay, so I think this works. So now we're going to run it against some test cases eventually. Well, first let's think about what's space and time complexity. So if we're thinking about space complexity, we're considering, so we're going to append to intersection and eventually return intersection. Okay, so we don't include any space that eventually ends up being returned, and so because we don't, these are constant space. These integer values, they're just O of one space. So our brute force approach, space, O of one space, because no intermediate data structures required. And time complexity, let's think about time complexity. So we go through, we increment I and j until they reach the end of their respective values, but we stop at the minimum of either I or j. So the time complexity is O of the min of len A len B, because when one of them reaches the end, when j goes here, and so let's just assume B is smaller than A, that's when we stop, because that's j will be greater than the length of, well, let's think about this. J will equal the length of B, and that will mean this condition will evaluate false. We'll exit out of the loop, we'll return intersection, and so this is like O of n or O of the min of these two lengths of these arrays. And I don't know if we can do better than O of n. So this wasn't, I think we went straight to the optimized solution. So let's think about, is there any way we could do this faster? I think no matter what, you have to iterate over each element within the arrays to check whether it's in the other array. So the minimum time complexity is O of n. We can't do better here. So in this case, we tried to find a brute force, but it was actually an optimized solution. So let's just change this. Optimized. So now we have to do implementation. So we've got our pseudocode here. We've got our space-time complexity. Now let's do an implementation. So we've got this trusty array set up. Our input is going to be A and B. They're going to be lists of integers, and we're going to return a list of integers. So let's do that. Intersection. We'll just copy what we did before and translate to Python. Length of A, length of B equals 0, 0. Length of A, length of B. And our stop condition was when either I or j is equal to length of A or length of B. So we said if I is greater than B j, we're going to increment j plus equals 1. Elif. The other option, we're going to find j, we're going to increment. So if I is less than j, we're going to increment I. Otherwise, we know that they're equal. And when they're equal, if I is 0 or AI does not equal the previous value, does not equal I minus 1, then we're going to append intersection dot append. We're going to append AI. We're going to append AI or AJ because they're equal. It doesn't matter which you choose. And whether we append or not, we're going to increment both values. So j, like I plus 1, j plus 1. Okay, so we think this will run. We may run into some edge case that we didn't consider, but let's see how we do. Okay, you guys, so no edge cases that we didn't think of any. So this is one edge case, is when the first element equals. We were able to think of that though. So this has been the intersection of two sorted arrays, all of one space, all of one time. Go out there and knock out that interview. See you later.